Yogi? Hi, Yogi.
Sir, good evening.
Good evening, Yogi. Start చేద్దామా?
Sir, yes, sir. Yes, sir, yes, sir.
Yeah. Good evening, my dear participants. So today we are entered into the second day of the session. Today we have two beautiful lectures. One by Pavan Ananthaneni, and the second one is Dr. N.V. Ramana. So both are dealing with the structural engineering for resilience subject. Okay. Now I'll just the first lecture will be from Pavan Ananthaneni. Just I'll briefly introduce you. Pavan Ananthaneni is a BTech student from Jain2 College of Engineering, Anantapur. Proud to say is our alumni and a gold medalist. He did this masters from IIT Bombay. There also he stood first in his class. Then he did his PhD from Christchurch University. Presently, he is director for Edge Consulting Engineer, Christchurch office. He is a both academician as well as professional engineer. He is registered for chartered professional engineer with over 15 years experience in design of widely variety of structures, industrial buildings, residential buildings, apartments, and other commercial buildings. He performed various seismic designs and assessments and peer-reviewed different structures. He is specialized in complex engineering analysis and sustainable design. He is having 15 journals to his credit, and he attended many conferences, please. So I once again say is our proud alumni of JNTU. Is a All India ranker in GATE examination also. With this brief introduction, I like to hand over the mic to Pavan. So Pavan Ananthaneni, yeah, Pavan, please take over the session, please. Yogi? Hello, Yogi? Hello? Yogi? Is it, am I audible?
Yes,
Audible, sir.
yes, sir.
Yeah, Yogi, are you not there?
Sir, I am here, sir.
Yeah, please, Pavan, please start the session, Pavan. You can present the slides. Yogi, Pavan kiche say.
Yes, sir. Pavan, sir. Pavan, sir. Pavan, sir.
Yogi? Yeah. Pavan. యోగి
Sir.
ఒక్కసారి సార్కి ఇచ్చి గైడ్ చేయి.
Okay, sir.
ప్రెజెంటేషన్ వస్తుంది, ఆడియో రావట్లేదు చూడు.
Yes, sir. Yes, sir.
అసలు అవును సార్, ఒక్క నిమిషం సార్. ఇక్కడ ఎవరు? హలో హలో సార్. అరే ఎవరు రావాలి? హలో ఓకే, ఒక్క నిమిషం ఉండండి. యాక్చువల్లీ ఇప్పుడు వస్తే స్క్రీన్ వస్తే చెప్పండి. ఇప్పుడు వచ్చిందా స్క్రీన్? వచ్చిందా? అరే స్క్రీన్ షేర్ చేస్తున్నాను ఇక్కడ. లేదు యాక్చువల్లీ 5G ఉంది. యాక్చువల్లీ మీకు అనిపిస్తుంది చూడండి కింద. యాక్చువల్లీ ఎంటైర్ స్క్రీనే కదా. ఒక్క నిమిషం.
యా, ఇప్పుడు యు ఆర్ విజిబుల్ నౌ. షేర్ ది స్క్రీన్, పవన్.
ఒక్క నిమిషం సార్, షేర్ ఆల్రెడీ ఉంది.
మళ్ళీ క్లోజ్ చేసి మళ్ళీ షేర్ చేయి. యోగి, యోగి
సార్ సార్ పవన్ సార్తో మాట్లాడుతున్నాను సార్.
ఓకే, నువ్వు వేసేయకూడదు ప్రెజెంటేషన్, లేకుంటే పీపీటీ తీసుకొని సార్ని చెప్పు.
ఓకే సార్, ఐ విల్ షేర్ సార్.
హలో
పవన్, కనిపిస్తాను పవన్.
సార్, కెన్
ప్లీజ్.
యూ హియర్ మీ నౌ?
ఎస్, ఇట్ ఈస్ ఆడిబుల్ పవన్.
Okay. Sorry, everyone. It's been a bit of a network issue, I guess. I haven't heard the introduction, but I guess Professor Shashi might have told you what I am really actually. And actually, I should thank Seshida for giving me this opportunity to present on structural engineering for disaster resilience, right? So in today's presentation, I will be covering 3 topics. The first one is actually a disaster, and the second one exactly means a resilience. And the third topic I would be covering is how a structural engineering plays a pivot role in disaster resilience. All right. In the slide, you can see 3 pictures there. It tells all the story. The leftmost one is the recent floods in Vijayawada. And you can see the impact that has on the city, right? And the middle picture shows the Gujarat earthquake, which happened 23 years before. And you can see the disaster is completely different. The scale and the type of disaster is completely different to the one on the flood event. And the disaster, what you see on the rightmost corner is the landslide that happened in Kerala in recent times. So you can see the scale of devastation and at the same time, the impact that a city or a town experiences in a disaster. So definitely there is a role for structural engineers to play to mitigate these disasters so that we can build a resilient cities which can recover in a quick time with a minimum economic impact or consequences. So without taking much time on this slide, I'll move on to the contents. For today's presentation, I will be covering disaster. I'll be covering disaster, what exactly a disaster means, and the types of disasters, and the extreme events that happened in India in last 30 years, and the impacts of a disasters and needs of a person who got affected in a disaster. And at the same time, I'll be covering some disaster management cycle and the role of resilience. And also I'll be talking about how disaster resilient infrastructure really works. And then I'll move on to resilience, what exactly means a resilience and what exactly resilience structure means and resilience building means with some examples. And I will share a couple of slides on resilient cities, classified as resilient cities in India. And also I'll briefly touch base on the planned city in Andhra Pradesh, which is gonna be a resilient city. And these up to now, this content is mostly non-technical. So just go through my notes on the slides. And from there, I'll be discussing one technique, how to achieve earthquake resilient building design. So from here onwards, it's pretty much purely technical. I kept it very illustrative with not much of mathematics there. So I will explain what a capacity design with few examples. And by end of this presentation, you should have some understanding on the disaster and also some understanding on resilience and some understanding on the capacity design, which is basis for earthquake design implemented by different countries in different ways, but the origin is basically the capacity design, right? So if you look into disaster, it's a loose term. Universally, disaster is basically a serious disruption to the functioning of a community, which causes human, material, economic, and environmental losses beyond a community ability to cope, right? What it means is any activity that creates major casualties or economic losses which a community can't cope, we classify it as a disaster. So this is from a UN, and the government of India has taken a very similar definition. So I'm not going to go through what exactly it means, but what it tells is if there is a substantial loss of life or a human suffering or a damage to a property or a degradation of environment of such nature or a magnitude that it's beyond coping capacity, right? So that's how a disaster has been defined, right? So if you look into extreme disasters that happened in India, from the top you can see one is Bhopal gas tragedy, and in that disaster almost like 25,000 people died and almost 6.3 lakh people got affected. So it's a big disaster, obviously. And the second one, and the Indian Ocean tsunami, where almost like 10,000 people died, and almost, if you see, almost like 27 people got affected or displaced. So, and at the same time, the recent COVID outbreak, It's also a man-made disaster which will come into place, and you can imagine the scale of disruption to the community and to the entire world. So obviously with disasters can have many impacts, and in the scale of impact can be different depending on the type of disaster, which I will explain in a minute. So, and recently, as I said in my first slide, the recent Vijayawada floods is a big reminder for us that we need to really plan for it. And otherwise, if we don't really mitigate it at this stage, the consequences gonna repeat again and again, which is not really good for the economy and the country, right? So if you look into the types of disasters, basically they are classified into natural, which means you really can't control it, and the other one is a human-made disasters, right? Within natural disasters, you got a geophysical disasters. This happened because of because of the geological disturbance, right? In this category, you can categorize earthquakes, tsunamis, avalanches, landslides, volcanoes, mass movements, and stuff. And the other, because of other natural disaster, is due to extreme weathers. Under this category, we can have storms, cyclones, tropical cyclones, which is very common, and it's getting more and more because of climate change. And because of these extreme cyclones, you're gonna have hydraulic disasters, which is nothing but flooding, and at the same time you got a biological disasters. Under this, you got a pandemics, epidemics, insect infestation. Other, the classic example for pandemic is obviously the coronavirus. So these all come under natural disasters. And the other one, other one is a human-made disasters. Under this, you can have an industrial or infrastructural damage or accidents like gas leak or a chemical spill or explosion or a poisoning or radiation, or a communal accidents like riots, terrorist attacks, are also accidents by human negligence, right? Under this, any major accidents, fire accidents, or a building collapse, where really a thought hasn't been given, and there's a human negligence which really caused major disaster. So if you look into India map, right? So what this picture tells you is you're not going to have the same type of disaster across the country. The type of disaster, what you can see depends on where you are and what you are really going to experiencing, either because of natural or or because of human activities. If you look into the coastal Andhra Pradesh, you can see this picture tells, this is very, I mean, the coastal is very much prone to tsunamis, and also it is prone to cyclones. And I mean, the chance of happening a major earthquake in this region is going to be very slim, because it's the peninsular plateau is very stable, right? Whereas if you go to the western side of India, the Gujarat, where you can experience earthquakes because of what you call the crust plate crushing into Indian plate. And at the same time, if you look into northern Himalayan belt, so earthquakes is one of the major disaster that can likely happen. And at the same time, you can have avalanches and flooding as well, which you can see in this second picture. So this picture is telling again the same what I said here. If you look into the Uttar Pradesh region, where you're going to have a maximum impact due to flooding, right? And whereas if you look into Andhra Pradesh, drought is another disaster for us, which you need to mitigate it. And other disaster that can happen in this region, as I said before, is cyclones, right? So by looking at, if you in this slide, I mean, if you ask me what's the most likely disaster that can happen, is basically flooding. So the floods are most frequent disaster in India and account for more than 52% for of total occurrence of calamities, followed by cyclones and landslides. For example, in Uttar Pradesh region or in Kerala mountainous regions, you do experience landslides. All right. So if you look into impacts of disasters, you can have physical impacts, psychological impacts, and also you can have social impacts, and you can also have economic impacts. The first and the type of physical impact varies from disaster to disaster. Say, for example, earthquakes result in increased injuries. In riots, people might be stabbed or burned and shot. Floods increase chances for spread of infectious diseases and epidemics and skin allergies. And at the same time, you're going to have a non-availability of basic resources and unhygienic conditions in relief camps. So vulnerable people and chronically ill persons and persons with disability deteriorate in health due to non-accessibility and non-availability of medicine. So these are basically physical impacts that any person or community gonna experience, and they're gonna vary from disaster to disaster, right? At the same time, if you look at the psychological impacts of a disaster, the psychological impacts can also have a wide range. The community can experience shock, denial, sadness, worry, fear, hopelessness, helplessness, and self-harm, blaming self or a god, grief reactions. So community gonna experience wide range of social impacts, which there's I'll come back who gonna play what role. If you look into social impacts, again, social impacts basically, which means it's affecting the routine of the communities. So if you have if you take Vijayawada floods, the recent floods, you can see how the community got affected, and as a result, in relief camps, privacy and routine of the families get affected, displacement and migration, loss of lives, and widows, and emergency of single parent families, and you can list many impacts. Some the summary is basically the community is gonna go through a lot of social impact. If you look into the economic impact of a disaster, the survivors compromise livelihoods subsequent to a disaster, financial loss due to damage to a property or a death or disability of family members, trauma, shock could prevent people continuing with work, increased chance of unemployment or underemployment, leading to the family being forced to borrow money and end up in debt traps, transport facilities disrupted. So you're going to have a different impacts. So the type of impact from one disaster to another disaster is going to be different. For example, if you're going to have an earthquake, you're gonna see a lot of economic impact with a lot of damage to the properties and a lot of casualties. Whereas if you consider other example like landslides, they could be very localized, and the impact may not be as big as an earthquake. So the plan and consequences are going to be very different from one type of disaster to another type of disaster, right? If you look into the needs of a person affected in a disaster, so this pyramid tells what type of needs a person would be needing in a disaster, from the bottommost, which is the utmost important in a disaster, which is a physical needs, which can be supply of food, water, blankets, clothes. Immediately after disaster, medicines and toilet sanitary facilities. And once the government or voluntary organizations meet the physical needs of a person affected in a disaster, then you really need to look at the security needs under which you can say first aid, physical safety of the survivors, health camps, emotional support, right? So moving further the pyramid, then it comes the psychological support, where you're gonna have a tangible and intangible support services, where for example primary and secondary support might be largely disintegrated. The available support needs to be retained and linked to the tertiary support like government, NGOs, and other institutions. And then comes the emotional needs, where uh, emotional needs help survivors identify the emotions experienced and communicate their distress in a meaningful way. The community members need to be given opportunity to talk about their emotions and their experiences as an aftermath of a disaster. And then comes the recovery needs, where it's a long-term plan, where government need to look at recovering the damaged structures and providing facilities, and it can be a short-term or a long-term plan. And then on the top is basically adaptation needs, where government need to uh, what you call build psychological competencies among the disaster survivors, so that their post-traumatic growth, adaptation, and coping and resilience gets improved, right? This is basically needs of a person affected in a disaster, and the needs can vary from disaster to disaster, right? So after talking a lot about the disaster and type of disasters and the effect of disasters and needs of a person in a disaster, how do we really control these disasters, either in India or elsewhere? Basically, in India, you got a National Disaster Management Authority, which is an apex body headed by Prime Minister of India. And the main purpose of disaster management body is basically to reduce the impact of natural and man-made disasters on a country's population and infrastructure. So there are 5 basically stages in a disaster management cycle. One is capacity building, under which you got a mitigation, and then you got a pre-impact, which means a preparation stage, and then you got a response stage, which happens during disaster, and then you got a recovery phase, and then recovery phase under which you got a what government or voluntary organizations or communities does after an event happens, right? If you look into state body, for example, Andhra Pradesh do have a state disaster management plan. The aim is to reduce the risk, losses, preparing for responding to natural hazards like cyclones, floods, and droughts. And also the one of the task for disaster management body is to develop urban master plans for growing cities. For example, Andhra Pradesh government has been developing master plans for cities like Vijayawada and Vishakhapatnam to consider disaster risk principles, and so that the flooding and cyclones can, the effect of flooding and cyclones can be mitigated. Right? If again, this is the same picture represented in a different form. The topmost curve shows what happens before an incident, and the bottommost curve shows what happens after an incident happens. So for rest of my presentation, I will be pretty much focusing on the before an incident, pretty much focusing on a mitigation stage. And if you look at what a prevention stage is, basically how do we really prevent disasters? For example, cyclones. One way to do is basically afforestation. Plant a lot of plants and trees help to have a community resilience, so that the chance of cyclones and temperatures can be, climate change can be mitigated. And under mitigation is basically, there are 2 aspects. One is process of elimination of psychological impact, and also physical impact, which I will talk in next slide. And the third is pretty much a preparedness, by utilizing advanced warning systems. Governments do prepare and reduce the psychological stresses and physical stresses of a community. And then after an incident, it's pretty much rescue, and recover, which I'm not gonna touch too much. Right, in this picture, what I was trying to show you is within pre-disaster phase, you got a prevention, and then you got a mitigation, and you got a preparedness. So for us as engineers, one role where we can really play well is at mitigation stage. So one way to achieve disaster mitigation is through building a resilient infrastructures and buildings. So what exactly mitigation means? Mitigation is a process of elimination or reduction of physical impact to the built environment, like buildings, bridges, dams, culverts, roads, etc. So basically what it means is we are really reducing an impact if any disaster happens. Right, if we look how actually a disaster resilient infrastructure works, is basically there are 6 items that need to be incorporated in the overall scheme or a strategic planning. One is to assess the risk and assess the vulnerability of a community or a region, and develop a risk maps and identify the potential consequences, and assess the likelihood of their occurrence. For example, uh, uh, cyclones, which we can see they are more and more often. So we do need to really pay a lot of attention and say we need to really revise our cyclone maps to account for increased cyclone occurrence, and accordingly the codes and standards need to be updated. And at the same time, the second item that need to be considered in disaster resilient infrastructure is basically implementing robust engineering standards. And the third item, obviously, utilization of advanced technologies, meteorological department data to which can give early warning systems, so that the community can be prepared and act and relocated accordingly. And then the third one is the infrastructure interconnectedness, basically connecting different infrastructures so that the community can have some access to transportation or energy and water after a disaster. And the final one is community engagement and education, where communities need to be taught what the possible disasters they can have and how they can mitigate it by building it according to the codes. And like as I said, disasters are very different. So the design for the different disasters vary. And if you classify, for example, earthquake resistant building design is very different to flood resistant infrastructure. And also what it means is, for example, earthquake resistant buildings, they need to be light and strong, whereas flood resistant buildings need to be at a height so that they don't get really impacted because of rise of water level. Right, that's what he says. Elevated structures or buildings on stilts to minimize water exposure. So what I will be covering for the rest of the presentation is pretty much earthquake resilient buildings, and I'll cover what a resilient means that, again, as I said, we need to work out worst strength factor. Let's assume this pier is subjected to 500 kilonewton of shear lateral force, and due to available bar size and strength reduction factors, the nominal strength is, say, 600 kilonewton. Means the capacity of that pier is 600 kilonewton. Now, if you apply O strength factor of 1.25, so which means you need to design for 750 kilonewton of shear force rather than 500 kilonewton of the shear force, so that you are absolutely sure that shear failure doesn't preside before flexural failure. And you can apply the same capacity principle for moment resisting frame, which in this case you see a 1-bay 5-story frame, and the beam sway mechanism is the most ideal failure mechanism. And you don't want to have a column sway mechanism, because it's going to collapse at very low drifts, and you're not going to have much plastic deformation. The consequences of column sway mechanism can be huge in relation to consequences of beam sway mechanism, right? That's what. And then if you have a close look at that beam column joint, what you're going to have is you got a moment demand in the top of bottom of the upper column, and moment demand in the top of the lower column, that needs to be equal to beam moment capacity, which is MPB, right? That's how equilibrium is satisfied. So what you need to make sure is no column yielding will occur at the joint, which means you need to amplify by O strength factor, this one, forget about dynamic magnification factor for now, which is generally around 1.25 to 1.5. So that column moment need to be bottom column or in the upper column, right? Again, this very illustrated. And to summarize, to summarize capacity design of a RC frame, to ensure plastic hinges form in the beam, you need to make sure column flexural strength is more than maximum likely flexural strength of beam plastic hinges. And to avoid shear failure, you need to have shear capacity of that member is more than corresponding shear force from beam O strength, which I'll explain you in a minute. Right? Say, for example, let's say you got an ultimate state where hinges have been formed and you got a lateral load. So this beam is got hinges at the both end, and it got a O strength moment capacity of MO, right? And this is purely due to earthquake forces, right? Once you have this O strength capacities of those beam, and then what you can work it out, the shear V is nothing but MO at the left and MO at the right divided by length of the beam, right? That's the shear demand due to earthquake forces, which need to be added with the gravity forces, which means to avoid shear failure of this beam, you need to really design for O strength capacities due to earthquake forces plus gravity, which will be significantly higher than what an analysis software will give you due to these earthquake loads, right? Similarly, for a column design, to avoid shear failure, you need to consider that subassembly and consider the equilibrium, where you got a O strength moment capacities at both ends of the on the left beam and the right beam. And if you take an equilibrium, you really don't have a gravity load because it goes as an axial load into column. So the shear that goes into column is basically MO at the left end of the beam and MO at the right end of the beam divided by height of the column, right? Which is what again explained here in this picture. right? So that's the same picture. The shear capacity or the shear demand that a column need to be designed is basically MOA plus MOB by height of that column. If you design for this shear, then you're really gonna make sure that the shear failure is avoided at any cost, right? So that's how you really make sure the strength hierarchy is followed, and you make sure brittle modes of failure are suppressed, and you make sure uh, beams hinge, which are the weak link if you relate back to the chain theory. And so that, if an earthquake happens, so these beams are gonna go, the first one's gonna fail. It's like a fuses, right? These are the fuse elements. And then you can't avoid hinging at the base, which is fine, because it's still a stable mechanism. And with this kind of detailing, you can really make sure there is no sudden collapse to the building, and you can make sure even at a 2.5% drift, it's still standing there, right? And right, with that, I want to just conclude few things. One one key thing is we need to understand, because of climate change, annual number of natural disasters is likely going to increase, right? We are seeing more and more cyclones, more and more flood events, right? Disaster management needs to be implemented for the towns which are going to be converted into cities, and also the newly planned cities, and already existing cities as well. It's going to be it's not it's a task one individual can do. It's a task entire organizations need to work together. And the government has a major role to play in disaster mitigation and preparedness and post disaster. Disaster consequences can be mitigated through resilient and robust structures. As I said before, the design will be very different for each type of disasters. Like, as I said, for floods, it's a different techniques. For earthquakes, it's a different techniques. And more importantly, government has a key role to play in identifying the type of disasters in a particular region, and developing risk maps, and identifying the vulnerable structures, and carrying out structural health monitoring, and fixing those structures. And public infrastructures need to be built by considering present and future risks. I mean, for example, a road is being built, you really need to think of a national highway, you need to really think of what will be future risks, right? Whether it's closer to a river, what kind of flooding activity that can happen. And as I said, it's not one if it would be foolish to say we can mitigate disasters in a day by a 1%. It's a massive collaboration from local governments to state governments to central governments. There is a major role to be played by academicians who are going to advise the urban planners and the government policymakers. And as I discussed, you can achieve earthquake disaster resilient buildings with the different techniques, by utilizing ductilities, base isolations, dampers, braces, rocking systems, etc. But the easiest way you can achieve earthquake disaster resilient building is by utilizing ductility, because you are retaining your conventional system, right? That's what the next point is. And one key thing to remember always: strong column and weak. As long as you follow the strong column and weak beam principle, when you design, and make sure those weak beams are ductile elements, and columns need to be designed for low strength demands, so that you suppress the shear failure, your building gonna be fine. And finally, as I said, disaster mitigation or management or preparedness, it's not a one-day process. We need to keep keep moving and educating ourselves, and play wherever we can our role, so that you build a better environment for future generations. With that, I conclude my presentation. Thank you very much.
Yeah, Pavan, that was a wonderful session, Pavan. Really,
Thank you.
like you started with what disaster, then what is the role you involved? Capital city coming up, capital city Amravati, and what are the role of citizens to make the society, how to counter this disaster, and finally you concluded with column and week. Wonderful. I hope everyone has enjoyed the session. A few quick questions, please. Any 3 or 4 questions? Yeah. If anybody wants to interact him, you can email to him or write in the chat box so that we'll post it to him and we'll get it clarified later. Okay.
Thank you, everyone. Hopefully you enjoy the next presentation as well. With that, I conclude. Good night.
Once again, thank you from JNTU side and from Civil Engineering Department. So it was a wonderful lecture. I'm very proud of you, boy. Thank you. Whenever, even though you are busy with your personal this thing, you have accepted our invitation and immediately you gave us a session. Thank you very much, Pavan.
Thank you. Thank you very much.
Yeah. Pavan Ramna, Yogi Ramna sir unnara?
Sir, uన్నారు సార్. హలో.
Yeah.
Sir, kindly provide the feedback link.
Yeah, it is in chat box, sir.
Hello.
Uh,
Nitu? WhatsApp open.
Sir, not available in chat box. I have chatted.
Hello?
Sir, please check in now, sir. Please check in now.
Okay. Receive, sir. Receive. Got it.
Yeah. So, the next Yogi, shall we start? Raghu, shall we start the next session?
Yes, sir. Yes, sir.
Yeah. So, my dear participants, once again, good evening to all of you. Hope you enjoyed the session by Pavan and Ananthaneni.
Yeah, sir.
This section is by one of my close friend, Dr. N. Venkata Ramana. He did his MTech and PhD from JNTU University. He is associate professor in civil engineering department from UBDT College of Engineering, Davanagere. He is having 23 years vast experience and also in which 5 is in industrial experience. He is a both industrialist as well as the academician. He is having 75 research publications. He reviewed nearly 70 articles. He is having national and journal papers of almost 55. And he edited 3 books. And he edited 2 chapters also. He is editorial in for many journals, and like he guided 8 PhD students, and he is having one DST project, and he is membership in so many organizations like IST, IE, and all. And he worked in several committees in UBDT for the development of the college. So now I request Ramana to take over. Dr. N.V. Ramana. Hello,
Hello.
Ramana.
Yes,
Yeah,
sir. Yes,
Ramana,
sir.
please, Ramana. Yeah, please now the session is yours. I'm handing over to you, please.
Yes, sir. Just a few minutes. Yeah. So screen is visible, sir?
Not yet, Ramana. Yeah, it is fine now.
Is visible? It's fine. Yeah, okay, yeah. So how to move? Yeah. Okay. So good evening, all the participants. Anyhow, it is the hard time to listen because of continuously means that too it is the dinner time for many of the participants. Sir, my voice is audible?
Yes,
Yes.
sir.
Yeah. Yes. So now I would like to continue the few more discussions about the earthquake engineering. So I'm adding the few things to the Pavan. So come to the topic is disasters. So disaster resilience in the civil engineering. Actually, thing is quantification of disaster resilience in the civil engineering. The topic is mentioned to me by the organizers. So, however, I am providing the few things about the resilience. The first meaning resilience means to build the capacity or else to find out the how much the capacity to withstand the structure. That is the two things. So if a new structure means you can design to desirable strength. Otherwise, already existing structures means up to what load it may be sustained. So those things may come to the resilience point of view. So previous speaker has given the disaster management. So here the meaning is, again, I am providing the 2 or 3 slides just for the introduction sake of you. So there is a disaster means the occurrence of the causes of damage, ecological disruptions. So ecology also not only damages, so you have to see the ecological disruptions also. And the loss of the human life. See, the human life is a much more importance we are giving. Basically, we are the civil engineers. So you have to see the life of the human beings by constructing the proper infrastructure, by providing the or by adopting the guidelines which are given by the some countries. So now come to the types of disasters. So there are natural disaster is there, man-made disaster is there. So if you see the figure here, the floods is there. So sometimes we are unable to control the floods. Let's come to the natural disasters. So it includes the droughts. I'm coming the next one. See, major natural disasters. The flood is there, cyclone is there, drought is there, earthquake is there. So, however, minor natural disasters also there. So this is the cold waves, thunderstorm, heat waves, and mudslides. If we come to the here floods, one by one, we will discuss. So for floods is regarding the floods, hydrological point of view, or water source, people will take the much care about that one. So, however, being a structural is also we have to take care. So if the flood comes, means how to protect our buildings. So next is cyclones. So whenever the cyclones comes, low pressures created, automatically wind also increases. So whenever the wind increases, that means the building structures which are located to especially coastal areas may be affected by the cyclone. So drought means automatically continuously there is no rainfall over a certain areas. So the people will unable to live there. So that comes the drought. There is no crop growth. So all those things may be affects. So whenever the drought comes means usually people will migrate one place to other place. So whenever the population migrated means the population density increases every particular areas. So that also may not be permitted for to some reasons. So next is earthquake. So being a civil engineer, we are taking the much more attention on the earthquake. That is the major one. So that we will discuss. So cold waves, we cannot obstruct this one. Of course, we can maintain. If you go to the north of the globe, then only you can expect the cold waves. So thunderstorms, whenever the rain comes means, thunders also will come. It also will affect. So that's also some human beings losses their lives due to thunderstorms. So heat waves, certain regions, especially if you take the globe at 0, so here 0 degrees, here these areas may be subjected to heat waves because of temperature. Sunrise maybe comes to directly, and the zone may be subjected to high heat. So heat waves may be generated. So mudslides means again the floods to here. The mudslides may be linked with the floods whenever our rains or precipitation in the form of technical point of view. The precipitation is more and more means automatically mudslides also will come. So sometimes the buildings may be constructed or small houses may be constructed with the muds. So those things may be slides because of the cohesiveness between the soil particle may be decreases. Whenever it decreases continuously, rain is means absorption of the moisture as well as the water content. So it may cause us to the mudslides. So these are the major and minor natural disaster. Sometimes we are unable to control all those things. My attention is here. These things we may not control because of naturally this may be forms. So next comes is major man-made disasters. We come to the setting of fights and epidemics, just like a COVID virus. There is also one type of epidemics and deforestation. So continuously cutting out the trees, automatically it comes to the deforestation, pollution due to the cultivation. So next chemical pollution and wars. Recently we have seen the war, Ukraine war, the countries between the Russia and Ukraine. So this is the wars also some of the disasters. So with all these things, human may be affected. So next is minor man-made disaster, accidents, food poisoning, industrial disaster, and environmental pollutions. So these things up to certain stage we can control, or by providing the guidelines from the government, either state or central. Otherwise, World Health Organization, some things we can control. But whereas if you come to the natural disasters, so sometimes we can predict, that means a recurrence period is there for every 35 years or 50 years recurrence period is there. So by taking the past data, so we may consider the design of the structural members or elements or entire integrity of the structural elements. See here, if we come to this image, so train access are there. So top image is this, the only thing is floods. Whenever the high floods comes means damage to the human will come, otherwise economical also maybe damages comes. So if we come to the second one, this is the man-made disaster. The control, the driver is not unable to control. It may be in different way he has performed its duties means automatically losses may take place. So here what I would like to tell to you is natural disasters will not be controlled. For that we have to see the protection by anticipating the things in advance. So minor disaster, major and minor man-made disaster, we can control by taking some precautions. That means here each and individual citizen has to take care. Then only we can minimize the man-made disasters. So this is the broad way of the disasters. Now my talk may be focused on the earthquake. So here this is the earthquake. So especially so far the previous speaker has focused on movement resisting frames. So here many times if you take the India or other countries, some few other countries, so still they are not affordable to go for the construction of the houses with the movement resisting frames. Otherwise reinforced concrete structures. Still many parts of the India, especially north side, for some up to some extent in south side also, rural areas, still they are going to masonry structures. So how these masonry structures perform during the earthquake? That is the major discussion today's. Now come to the introduction. So here, if you see this image, so here focus, a disturbance may occur in the earth. So whenever this occurs means automatically this may be disturbance will propagate that energy. If we call that as the disturbing energy, that energy may be propagated. So one place to the certain up to certain distance. Then slowing on, it may be nullifies. So energy dissipation it takes place. Whenever energy is dissipating means automatically the energy may be travels, a disturbing energy may travels. If any structure is like this means it may be hit. The energy in the form of waves that may be hit and it will causes the disturbance for the building. So that means it make the small movement, lateral displacements. Okay. So major thing is what is the reason here inside? The question mark. If you say, I will take the one example. If you take the small stick, a small stick length is very small. If you apply the movement continuously, at one stage it may be breaks continuously applying the moment is increasing. It may breaks in two pieces. That means whenever they break the pieces in two pieces, mean let it be you are taking a small stick, wooden stick. So that is the brittle material. Whenever it failing the in two pieces to form a two pieces means automatically sound also will come. So same thing may be happen in this inside of the earth. This may be the one of the reason. I cannot say this is a perfect reason, one of the reason. So that's why slowly the disturbance may be created. The energy may be boosted here. This is the energy. This may be the time. So horizontal axis I'm taking the time, vertical axis I'm taking the energy. The disturbing energy may be continuously increased, just like example analogy you can take the stick. So at one stage it may breaks or rupture may take place with the pulse. So whenever it takes place means immediately the energy may be releases, it come down again. Again slowly the energy is boosting up, the disturbing energy is boosting up, again it may go and it may be. That means it may take the so many years also sometimes. So that's why whenever the energy is boosting within the earth, automatically it may not be sustained for that energy. At the critical point it reaches means then immediately it may be a rupture one over the plate to other plate. Otherwise one landmass to other landmass. So that energy will hit this building or any structure, whatever it may be, either road or infrastructure. So major attention is buildings because of many are residing in the houses. So that's why whenever it means this performance may be changes. It may lead to collapse or partially may be damages. So you have to anticipate this disturbing energy in advance. How means we have to see the back data of the Earth globe. How many times particular area is subjected to. So at least by taking the past data, we can get to one analysis. Same thing we will get in the future means we cannot see. That maybe increases or maybe within the less than the previous existing the disturbance. So that's why that goes to the visualization of the individual designer. Now come to the here. So earlier this disturbing energy, how it can create, how maybe it may be inside it may create means there are 1, 2, 3, 4, 5 reasons is there broadly. So tectonic activities, so there are plates movements are there that we are calling the tectonic activities. This volcanic activities, the eruption of the liquid from the one layer, from one of the layer in the earth. So automatically this may be erupted wherever the weak faults are there. So through that one it may be erupts. So one more is landslide. So sliding is there. So again imbalance maybe takes place. Next is bursting in the mine. So the mine activity means we have to extract the some minerals. That means raw material. So to get that one means we are getting the explosive materials. Then we are creating the bursting. So that's also will give the some disturbing energy to our nearby residing areas of the houses. So next is nuclear explosions. Unknownly some explosives means takes place to the nuclear action means that's also will causes the disturbing energy. So these are the factors we may consider for the creating of the this type of disturbing energy. So now come to this one. Wherever the it creates means that point we are calling it the focus. Many times you can see whenever the earthquake comes means here and there over the globe, then in the news you can see the focus. Next immediately it will be giving the in the news epicenter. That means wherever it is generated means that we are calling the focus point. Exactly perpendicular distance that is the called we are the epicenter. So next is wherever the building is located means that is the epicentral distance. That means the too far away from the epicenter means the disturbance for our structure may be less. It is near to the epicenter means the disturbance is more. So where it is located also very important. Sometimes in Gujarat, maybe sometimes takes place the earthquake effect means we cannot felt in Andhra Pradesh, we cannot felt because of it may be long distance is there. So recently in the Telangana also a little disturbance was happened at particular location. So that depends upon the, for that also we will provide the scale, Richard scale. So next is how it may propagates, the question mark. See, whenever if you take anything is, if you take a water body, just like a lake or pond or small water body, if you throw a stone in the water, it will create the small disturbance to the still water. Whenever you are throwing the stone means immediately a disturbance maybe travel in the form of waves. It may touches the boundaries of the lake. So whenever it touches means again reverse back it may comes. So to and fro motion takes place. So still that may be nullified due to the friction in between the particles existing in the fluids. So it may take time. So same thing may be happen in the earth also. Same thing. So that's why if we take the movement of the waves, how it may be. So only here compression and tension so takes place. So that we are calling as the primary waves. That means where these waves may be propagated means see here from focus to here to reach epicenter and epicentral distance here. So it may be travel in the form of waves. So what type of different types of waves means it may be here we are discussing the 4 types of waves that we are calling the P waves or primary waves. So this may action may be see this is the one just like a block rectangular block just like a beam element. We are seeing this each and every element see the element maybe only compression or tension that happen. So if you come to the secondary waves, see the secondary wave transmitting medium direction to the at right angle. So propagation, if you take this means it may propagate like this, just like up and down. So next form is that we are calling the love waves. It forms in the horizontal direction. So that is the movement may be like this. It may be like this in horizontal plane. It may move like this. So next is Rayleigh waves. Not only moving in this direction, almost it may accompanying with the twisting also. So out of 4, that is the primary waves, secondary waves, and live waves, and the Rayleigh waves, which is the most dangerous for our structures means this is the Rayleigh waves. Because of not only movement is take place in the horizontal direction, the rotation also will take place. Unfortunately, many times our structural elements are the capacity of materials for the twisting is less compared to the axial compression and axial tension. So that's why. So these Rayleigh waves are most affected for our building structures or anything, whatever. That means depends upon the material capacity. If you take any one material, so the material, if you have to see that how it may be resisting capacity in compression, in tension, in torsion. That's why the curriculum, we can see that each and every chapter we may teach to the students. So all together we put at one time and we will design the structure. So that's why whenever you come to the Rayleigh waves, both horizontal and rotation will take place here. So this is the most affected waves this one. So damages to the structures maybe causes more damage structures to the Rayleigh waves. Again, that depends upon the intensity also. So these are the waves may be propagated from the focus to epicentral, epicenter to epicentral distance. Next, come to the plates one. That means I said very quick here, there are 4 regions here. So here, so these regions may be causes to the disturbing energy for the earthquake. Next, move to the here. So here plates of the lithosphere. What does it mean? if you see very closely this image here, so here at center of the, taking the earth as a one unit here, inside if we take the outside of the figure, the layer wise, so here center, this we are calling the solid. So in case of to lay some distance, this is the liquid. Again, the material is the top or the over the surface of the earth we are living. So here, if you see, this is solid one, this is solid one, this is the just like a liquid. If any movement happens in the liquid state, means automatically these top layers may be subjected to disturbance. So for this, he is giving the good example here. See, if you take any vessel or tumbler, or we are giving the heat energy, automatically the water may be here. So inside this water particle, just near to the heat energy, water particle may take the heat energy that is due to the transmission. So automatically this, whenever the water particle take the heat energy, it may become a density become a lesser. So whenever the density whenever the density become a lesser means this may travel to up. At the same time, top level water, that is cold water, may comes to the bottom. So this process may take place till the each and every particle of the water reaches to almost all equal intensity of temperature. So that's why this happens. Same thing will happen. That is the convective currents. This we are calling the technically convective currents. So this also will happen here. So whenever the heat energy comes to here means automatically something may be happened in the liquid state. Automatically this type of convective currents not working. Huh? Check it. So anybody is working? Audience
Yes, sir. Yes, sir.
Yes,
is
sir.
working. Yeah. So whenever the this comes in liquid, this type of convective currents will happen automatically. So any disturbance in the liquid means automatically this top layer also will try to subject to the disturbance. So next question is, here you are providing the heat energy. Where is the heat energy here? Question mark. The heat energy, who will supply the heat energy there? So if you come to the inside, the inner core and outer core and mantle. So very broadly we are saying this is the outer core, this is the inner core or mantle. So sometimes the radioactive materials are available in the earth. So these materials continuously emptying the energy. So that energy is also one of the cause for the taking the convective currents within this the outer core liquid areas. So not only that, here pressure differences are there, and the same time temperature differences are there. So many factors are there. Out of that, I took the in one region just like a convective currents. So this may be the one of the reason. That means if you see the globe, Earth globe, there are many just like palms, just like a plates. So that I will come a little later. Okay. So now come to the faults. Next to the faults. So if you take any one faults, as previously I told you. So whenever if a small stick you apply the movement, otherwise force, axial tensile force, otherwise axial compression force in all stages, it may leads to the break. The one reason. That means continuously you have to increase the movement in this case. You have to increase the tensile force continuously. At one stage, the material will break here and here. That means disturbing. So same thing, if two things are there, means continuously this and you try to move one over the other means. So this is separate, this part is separated, this part is separated, moves like this. So otherwise, this is the one layer to layer. Let's see here also same thing here, but here movement in the other direction. So out of these things, anything maybe comes. So during this stage also, the rupture may take place to the one solid mass to other solid mass means disturbance may be created. What I told you here, this example, when I was try to break at the edge of the break means it may give the sound. So there also sound will come at the same time disturbing also will creates. This may be the reasons. So next is plate boundaries. See here we are taking the two thing landmass. Suppose we are taking the boundaries like this. So it may be slides one over the other. Not only these regions here. If the movement is taking place in the horizontal direction, that means in the lateral direction to this direction to lateral direction here. So sometimes may not be exactly this might happen. It may be slides like this. So if you take this is the one layer, this is the one layer, it may be sink. Otherwise, it may go up. So this also may happens. Next to see here. So these things maybe happens like this part and this part, push like this or this, come like this. Many times you can see this type of activity from the volcanic activities. That means previously I told you this one, this outer core. So whenever the temperature means the pressure difference is there means here high pressure is the lower pressure means any loopholes or some gaps are there means automatically this may comes to the higher pressure to lower pressure, it may comes to take the path also like. So it may comes in the form of volcanic activities over the globe. So in some countries you can see the volcanic activities is very active. So this may happen, the field formation like this, it may happen. See the now come to the this is the just introduction. Now come to the reality. So here erosion plate is there. Next is Indian plate is there. Two plates are there. That means if we take the globe, if we spread it in the plane, we can have the some plates are there. Just like a piece of, if we provide a piece of papers, if we throw on the water, so whenever the create means it gives the some disturbance, the plates may be moves. So same thing maybe happen here also because of water core liquid is there. So here erosion plate and Indian plate, two plates are there. So due to this movements, the Indian plate is moving or riding over the erosion plate. So that's why sometimes you may heard the news either in WhatsApp or news, paper news, the Himalayas height is increasing for after few years. Yes, it is truly correct one. That means see here, in the 55 millions ago, this was here. The case is after 28 millions is moved here, and 10 years ago this moves again. It may be ditches to the erosion plate, the substruction takes place, the rising of the takes place. That means see here, this plate is coming and is not going here. That means if we assume this is the Indian placement, it's going up here. So same thing will happen here. That means if what you understand from this means, so these boundaries mean these boundaries. So unfortunately, this area in our Indian map, north zone, especially this northeast zone and Uttar Pradesh and up to some up to Gujarat, to all these areas may be earthquake prone areas. Very much more intensity is there. Okay, this you can see here. So in mid-Atlantic ridge also forms here. So this you can see in the here San Andreas, this type of ridge activities you may see in this image. If you come to the Indian map means this is the things is happening. So that's why many times what we say that, especially at the junction of the erosion plate and Indian plate, we should be much more care take about the earthquake. So that's why many times these type of many types of houses or buildings they may be designed for the against the earthquake. See here, this also will says the rising of Himalayas. So one is moving, other is the plate is moving like this. This is moving. So reality wise, this also one of the picture images here. You study on a seismic faults in Haryana. I shown that Indo-Gangetic plain. So this type of disturbance also created. So these images, a valley is created here. Now come to the Indian map here. Already I said you same thing I shown in this image. So this region, this region, this is the substruction region, thrust boundaries. So next is fault and fault zones. If you take the red lines of the fault zones, So all over the India it is distributed. So much more attention you have to take place that is thrust boundary and subsectory boundary. So these areas, whatever the areas the people are living in this area, we have to design our buildings for these areas. Of course, here Andhra Pradesh and Karnataka, otherwise Maharashtra is there, a little effect for the earthquake compared to the north regions. Now come to the what did I shown in 2002 image very long back in 2012 again 2016 it was revised. So initial stages these are the more zone 1, zone 2, zone 3 and zone 4 very long back in 2002. Wherever the red is zone 4 means that is this area red part wherever the red part is that means is the more affected areas for the earthquake. So let's start with the zone 1, that is the blue indicates the zone 1. Later, by observing the Bhuj earthquake, this graph was changed. That's images of the Indian map. The zones were changed. They merged zone 1 and zone 2 as a made it as a zone 2. No question of existing of the zone 1. So that's why even see Gujarat also here, the Jammu Kashmir area, the seven sisters of Northeast. All these things are more prone to the earthquake. So people who are living here, we should seek them, be caution about the earthquake. If we go back and see the questions here, past earthquakes, very recent in 2001, with earthquake, the scale of the magnitude is 6.9, the scale is there up to 8, so it was 6.9, nearly 7. So see here, 14,000 people were died. So this is the very pathetic, even though technology is there nowadays. However, still we are not taking care about the things. This type of disaster things. It is not a joke. 40,000 people with one incident was dead means. Imagine they are our relatives, otherwise our friends means how much we felt bad. So that's why Bhuj earthquake is in Gujarat. If you see the earlier in the even 2002 only, it was identified Gujarat. A part of the Gujarat is also more prone to the earthquake. Unfortunately, one of the coordinator has completed PhD in Gujarat state. I think Raghu Babu, one of the coordinator. Okay, right. Of course, later by seeing this effect of Bhuj earthquake, we changed this map. Indian map. Again, zones were changed with the colors. So those who are interested in this area, you can get the 2016 or 1893 code. Next, come to the this is a very brief introduction about the earthquake earthquake effects. Now come to the previous speaker. Once again, I'm saying the previous speaker more attention has taken about the structural point of view for the moment resisting frames. Now come to the masonry. See, if you see the pie chart, this is up to 1950 to 1999. I'm showing here the majority of the pie chart area is occupied by the collapse of the masonry buildings. The share of the pie chart more for the masonry buildings. So next is a small part is their timber building. Collapse of the RCC, this also second major share. Fire following the earthquake is a little share, and landslide okay up to some extent considerable point. Other causes is also. See, pie chart almost all 1/3, nearly 40 to 50% of the area is just because of collapse of the masonry buildings. Because of basically we're not so rich country, we are developing country, so that's why our population is also more. Number wise also population is more. That's why every family in the Indian scenario cannot afford go to the reinforced concrete structures buildings. Of course, nowadays the government is supporting to construct the buildings by providing some funds still we are unable to provide to all of them. Now more attention to the masonry structures. How to minimize this effect? What may be the effects for the structure here? If we come to the again structural dynamics and masonry buildings, the quasi-static is there, resonant is there. So there are two things are there. So resonance is there. One term is natural frequency is there. So each and every element have a natural frequency. So omega is equal to root k by m. So this is the k is the stiffness of the element, m is the mass of the corresponding the element structure. As a whole structure may take this. So this is the natural frequency. So this natural frequency is depends upon the material properties. Just because of taking the stiffness and the mass of the elements, can take and can find out the natural frequency. The forcing frequency, that means whenever they create the force, already I said in the starting, the disturbing energy may be created within the earth that may be propagated or diffuses to in all directions. So if you take any one structure means you can expect that it may move in three directions, the disturbing energy. So one is vertical direction, and the other two are the horizontal components. But many times we are taking the count into the only two directions, horizontal directions. The vertical directions may be, of course, we can consider. However, we may neglect because of that. Maybe the intensity may be decreased due to self weight. The balancing may sometimes take place. Other this effect and this effect may be more compared to the vertical effect. That's why our studies and our textbooks, majority of the textbooks may be focused on the only in horizontal directions. So whenever the forcing frequency means force have some frequency, that force frequency, that means that's also linked with the sine or cos curves. So that's also frequency is omega. That is forcing frequency. So this frequency and this frequency, natural frequency and the forcing frequency should not match. Maybe greater than or maybe less than. If two are matches means it can the resonant. So resonance means whenever the resonance comes means the two Wn and so Wn is equal to W means immediately the structure or elements may subject it to vibration. So it goes to maximum level. Though sometimes in graphical you can say that infinity, but it has some value before failure. So that should not be matched. So that's why even at lower studies, we may see that whenever the march fasting is there on the bridges, the commander or also the leader may say that to stop the march fasting. The reason is these soldiers may create the disturbance. That means it will generate the force by making the step on over the bridge. That frequency and natural frequency matches means the bridge may be susceptible to vibrate or leads to the failure. Generally, you may study it in the lower classes. Only simple thing is the sense. Properly the time some you of us maybe understand better way, some may not be. Whenever the age is goes or means, we can understand in proper way. So that's why. So here the resonance is the very important one. So it has own limitations. How much it permitted? The again question mark. The displacement takes place. A displacement and drift maybe takes place. That means one particle to other particle if we connect to the relatively displacement that we are calling as the drift. So if you take the displacement means even element, that means just like if we take this beam, if we go to the analogy, just like entire mass is concentrating at the floor level or slab level. That means whenever that creates the disturbance create means this may be vibrate like this. That means this may be displacement. That displacement should be within the permissible limit. Just like only we are taking the single degree of freedom. I am going to little analysis. So single degree of freedom means only I am taking the only, so suppose I am taking the mass is like this. So I am permitting the only this delta. So can I expect the only in vertical direction? Yes, you can expect. Sir, can I expect the in rotation? Yes, rotation is also permitted. So that's why degrees of freedom considering by the designer. Sort of the vertical, horizontal, and rotation, and each and every x direction, y direction, z direction means you have to. See, if we come to the z direction, rotation is there. If we come to take the about the y-axis, also rotation is there. Different way you can consider. So many times in our academic curriculum also, we much attention for the displacements with the delta value. So for this also code is there, earthquake code, they have provided the limitations. Strictly speaking, our softwares may provide all the information. The resonance frequency, natural frequency, forcing frequency, ratios, and displacements in x direction, y direction, movement displacement, all will provide. But the thing is how to provide the equation that is important. So one more thing, we are taking the force effect and displacement effect. So in between the whenever this force is there means whenever this force is created means this force has to travel through the structural members to top level. That means this level. Why means the main entire majority of the mass is concentrated at the floor level only because of beam and slab is located more or less at one place. The columns will act as a element. Mass, if you take the entire the elements of different mass and put it at one place means this may comes to lumped mass. So that's why. So here to travel this stage to here, in between the journey, the material will absorb the energy. That we are calling the damping C value. That's why if you take the equation static equilibrium equation, static dynamic equilibrium equation, m double dash into k c into x double dash k into x is equal to f of t. This is the equation. That means whenever you are taking into consideration of the damping means the C matrix will come. So that is a thing is if you omit this one means only two terms, one is stiffness and the mass will come. The solving of this equation, differential equation and getting the values maybe dynamics point of view. That means what I would like to convey here means whenever the force is there means this also you can represent in the form of frequencies just like a f sine omega t or cos omega t like this anything. So f is equal to f naught into sine omega t sine omega t like this or cos omega t. So this is 5 into sine omega n into t here or 3 into t something values. So that means this all things may be changes with respect to time. One thing you have to remember the displacement equation and acceleration, that is the responses. Responses means major responses are displacement, velocity, and acceleration. These three are maybe changes with respect to the time. Ultimately, the differential equations yields or gives to us is how much the displacement is taking place with respect to time, how much the velocity is there, how much the acceleration is there. One more question may generate in our minds. So can you, why we are providing the all three? That is the question mark. One is enough to reference, no doubt. Once you find out the displacement to the ds by dt, that is the velocity, again dv by dt, that is the acceleration. But providing the information just like f is equal to ma, that is the Newton's second law. So this disturbing energy we may be linked with the in the form of f is equal to ma. So acceleration with this acceleration, the formation of the things is very easy mathematically. That's why more attention will give the acceleration spectrum. Okay. So that may be applicable to all, but how far it is applicable to our masonry buildings, that we will see. So whatever I says, this is the natural period. And this is the average response of acceleration coefficient. This is the acceleration SA by G. So SA by G, there is the coefficient. Added the acceleration into some factor. So K into Z value. Z is the some K factor. So by seeing this natural period means to make a one natural period, we are taking the disturbance in the form of waves. One wave you have to take the time period. So it linked with the structural dynamics. By seeing the natural period for the each and every structure, again depends upon the hard side, medium and soft soils where the our structure is residing or resting over that. That you have to take. You can find out the say by G. So once you find out the spectrum acceleration, then your journey start to solve the or to find out the responses of displacement, velocity, and acceleration. Okay, any of that we can say the earthquake resistant design of buildings. So how to develop this curve and all those things you can, that is the second story. Now come to our masonry buildings. See, this is the example for the masonry buildings. Uh, See the all over the world because of what I said, many families are still below poverty line or at the starting stage of the middle class. So all the middle class starting level people may not afford to go for construction of the reinforced concrete buildings because of financially maybe differ is there one family to other family. Now come to the in other part of the India. Will the stone masonry structures are there? Yes, it is there. See, if you take the Greece, these type of stone masonries are construction. Of course, civilizations will develop very long back. People are moving one place to other place, whatever the technology they knows they have shared. One group of people to other group of people, then slowly dissemination of the knowledge, dissipation of the knowledge is there. Slowly they are adopted the new things from one set of people to other set of people. This you can learn about history of the world history or Indian history. Now come to the one more country. I will show the country Italy. So next is Turkey. So there also structures are there, stone masonry structures. So next is Algeria. So this also 6-story stone masonry building is there. Next is India. Next is Nepal. So all these things, see in Nepal, India, Algeria, and Turkey, one more is Italy, so Greece. So one thing you should understand that if the people are going to construct the buildings with the stone masonry means, in other way we have to throw a light the availability of the material. That means whenever the stone material is available means that too it is available for the lowest cost means usually people will go to build with that. So that's why in and around the area around the India for country, some other countries also there to build the houses with the stone masonry because of naturally material is available. The stone is maybe cheap compared to the RCC ingredients, just like a reinforcement and the cement, all those things. Okay. Next, of course, slowly people are changing. Their economy position, GDP values increases, then people are changing, taking place. Still, many houses are there with this stone masonry. Now come to the detailed picture here. So here timber post is there, transverse timber is there, here stone column pedestal is there, longitudinal timber is there, timber plank with successive beams are there. Next is intermediate pieces are there, these pieces are there. Next is uncourse random rubble stone masonry is there. These are the elements I am showing for building components. So if we closely observe, even if you go to the rural areas, even now also, some houses still we can notice our forefathers, our grandfathers, our houses, they also constructed houses. So those houses, see, closely observe what I would like to convey here. Sometimes there is no proper joint, simply resting over the other. That's all. That means if we take the stone column pedestal here and timber post, so there is no joint here, simply resting, just like a simply supported cases. So these pieces, intermediate pieces also resting, joint were not there. So previously I told you, whenever the structure is there means if any disturbing event means it has to distribute to through the members to top level. That means inertia force it comes. That means it goes to moves, means it may moves, it goes to back like this. That inertia effect is there. That means the member should be transmitted the disturbing force to top level. That is in the even previous slide also shown here. On the first slide, again I'm showing the same slide here. See here, this force is transmitting and this will affect the quasi-static as resonant. Now come to this picture. So there is no perfect joint means whenever the disturbance comes means a small displacement takes place one member to other member. So there is no joint is not perfect. What happened? It leads to the failure. So individual element behaves in different way because of material properties also maybe differ. Some metals here, timber post may have some resisting capacity to take the lateral loads, and stones may have a lateral loads. This uncoated random rubble story will take the properties, different engineering properties in different way. So there is no, there is a mismatching of the compatibility of the material properties. So immediately it leads to the failure. How come to the here? Floor and roof structures. If you take the arch structures, even now also Britishers were construct. If you go to the move one place to the rail, here and there we can notice it this type of structures. So whenever these structures means this joint is there here, abutment, abutting faces. So these abutting faces may be very strong. Unfortunately, here we provide the loose joint means the arch action, the purpose of arch action will fails. The purpose of action fail means if you take this component is vertical component of here, the bending moment is reduced due to the horizontal component that you have studied in the structural analysis. So here, so whenever the resisting the developing of the horizontal thrust and vertical reactions may be improper way, design improper way, connection is there means automatically the entire thing maybe leads the collapse. See here, this point. So this point, joints be perfect. Simply they are butting only. How you are providing this joint? Whether it is the rigid joint or semi-rigid joint or flexible joint. Otherwise, whether it transmitting the forces one part to other part, the question. If it is transmitting means how magnitude wise, that you have to think. Because of this material is brittle material, it may not permit to move the displacement here. That's why if this joint is weak means automatically entire thing maybe leads to fail. Arch action. Otherwise, in other way, arch action may leads to fail. Whenever the arch action fail means probably our designers might be designed by taking the arch, that is the horizontal thrust action. So it may loses its functioning. So such type of failure, real failure, you can see here, the right side hand of the figure. See here something, brick walls. just like a brick. Stone masonry. Next is timber joints, trusses. See here, wooden beams is there. Here, tile flooring is there. So in between the wooden planks also there. If you are nailing one to one like this, simply you are resting the wooden planks over the wooden beams. Over that, you are providing the ballast fills, otherwise tile floor. If any inside, that means from bottom to top level, it is the roof level, it creates means how to distribute the disturbing forces, member to other member. Because of joint is not there, perfect joint is not there. So it's also one of the failure. Static condition means well and good, no doubt. But whereas come to the disturbing energy or disturbing force means then the problem comes. If you see the old structures here, so here and here, see here, masonry was failed here in Nepal. Even our rural village also you can see this type of wooden beams, circular wooden beams. Okay. Next is stone masonry walls. See here, wall is taking here. Next is slab is with reinforced. Nowadays, certain some families even now also even house is there. The top is provided with the mud layer. So slowly they are removing the layer according to their financial capacity. They are removing. They are providing the reinforcement slab only. This reinforcement slab simply resting on the walls. Whether you are providing the perfect joint in between the wall and the slab is no. So whenever disturbance is created means it may be propagated in all directions here. So when this may be try to move, push, either to and from motion will take place. That time, so this behavior and this behavior may be different. Next is here. See the joint here. So one more observation is, so here stone masonry is there, stone is there, mud mortar is there. But being a civil engineer, what you have to think is, what is the bonding capacity for the mud mortar? That means it has to adhere stone to stone. What may be the bond strength? Again, strictly speaking, shear strength may be the dominating one. So again, shear strength is the function of the cohesion and angle of internal friction. So here, probably you may use the clay size for taking that one. So what about the C value? Whether our disturbing force will be transmitted to by the bond strength of the motor from stone to stone piece to stone piece? The question. So if you take the mud motor, if you take the cement motor strength, there is a large difference is there magnitude wise. So that's why even small intensity of the loads may lead causes to failure with the masonry buildings. So next to come to the foundation here. Inside it is generating the force, disturbing energy, it may be transmitted in all directions. If you transmit it to bottom level to top level up to this or up to floor level, if a small disturbance is a disturbing energy is more here because of if you travel to here means certain energy may be loss may take place, only the damping effect will come. Energy reaches to the top level also decreases. But here during the transmission stage, each and every particle, the contact is required. The transmitting forces. How much the energy may take place for this the joint of the masonry, stone mason. Question is the mud mortar having the capacity is very less. Here also crack may be propagated. Here crack is propagated. Probably sliding maybe comes like this. Forces may be more means it may try to expand laterally or bulk. Whenever bulk means the gap may be. I will show in this next slide. So this see here, this image is the real image I'm taking here. So this structure is good, but here to here transmitting stage, the materials may be separated. The stones were separated from the mud mortar. So next is see one more the joint. This is the one more here joint. Okay. Next is how the shape of the stone also it impacts a lot. Very important one stone how it impacts. See sometimes we may provide only stone walls one over the other that means piling up. There is no mortar also. Of course, this is a fire minor works. Even though minor works, a person is doing his work immediately earthquake comes means small disturb means if he's not notice sensing it may not sense properly. Otherwise, aged people are there means even to come out from that place to means it may take time. By that time it may fall means the human loss may take place. That's also possibility is there. See here, almost all there is no mortar. So here in certain areas the motor is absent. See how they are providing here. So this providing here. So each and every layer of the stone should be provided with the mortars. See uncourse semi-trussel stone masonry. The size of the stone is also not a one layer. Up and down layers are there. Small stone, different type size of stones are arranged with the mud mortar. The capacity also that means whenever the this type of motor means motor will occupy the more the connecting motor is required more and more. See here the size of the stones also may be different. One is bigger size, one is smaller size. Again, it may not be properly jointed. So next is see the cross section of the wall. Real image we can see here. So whenever it comes means the position is perfect shape is there here. Here there is no perfect shape. So imagine this. This is the one stone here. This is the one stone shape is like this. Pressing is there. That means the if you provide here the small stones of the masonry means it may take the little time to collapse. Here, see the here almost all very big joint. The question is, sir, hitting is like this. You are showing in this way. It means already previously I said in 3 dimension you can see the disturbing energies. Sometimes along the movement also. So in vertical direction, okay. If horizontal direction means if you come to here, immediately it may take the more force to detach. If you come to here, there is no much force is required. Immediately transmitted again it goes to here. That means whenever it's separated means this part and this part may be separated. It may lead to the failure. So what to do? The question mark is how we can just see here timber bands we are providing. See closely observe here. It depends upon the availability of the material. We have to provide the connection here. So this side to this side corner. Why the more attention to corner? Again the question mark. Whenever the transformation stress or stress flow takes place one area to other area means the sharp edges may not there is a stress concentration may take place. A smooth flow of stress may not be there. It is the major reason. So that's why we have to strengthen this area. Okay. Not only that, one joint is also very important, the corner joints. So in order to make a more protection means we have to provide the timber bands. Okay. Next is see here, actually masonry. Size is a more or less is same. That if you close observe the joint is here is there. So this and this, of course, even now also in brick masonry, we can see the type of joint. If you provide the joint exactly here means disturbing energy generation in 3-dimensional. So immediately the cracks may be propagated along the one particular line. So propagating vertical line, propagating in the diagonal, it will take a little more time to propagate in diagonal wise rather than the straight because of solid material is there. Provided the joint should be staggered. Okay. See here, this and this is matches here, and this is matches here. This is not the straight here. Even sometimes unskilled laborers also at certain location they will provide brick over the other, not in the staggered way. So because of they don't know about the what may be the process going on if force comes. Because of sometimes unskilled. If they are work under the skilled laborers means skilled laborers maybe guide them. Yes. Next is same thing you can expect here also in Switzerland. Same the collapse, damage. So here damage, here damage. The why all these things are fail means we are not bothering about the force or stresses distribution from one place to other place. That is the major one. See how buildings are collapsed. Now come to the technical lack of structural integrity. So probably this term also a pre-speaker has used this one, structural integrity. So whenever the force is comes means, so see here, this effect, the pushing effect is there. So unfortunately here and here is joint is proper way is there. So in between the bulging action may take place. So out of the plane. So plane is there here. So force is acting means immediately for this point, movement is acting. So it may try to bulge in lateral direction. So whenever you try to lateral direction means here joint is not proper way. That means more displacement takes place here. Sir, can you expect the here displacement? Sometimes you may expect at the bottom also. Entire structure may move. Sometimes it may not be moves. If you provide a rigid that remains so solid slab, more dense material are providing here, light material are providing means here displacement possibility, here displacement, here fixity is there because of it is linked with the ground, confinement is there. So if you come to here, there is no much confinement, automatically it pushes. So see this figure, this wall maybe comes outside. If there is no much force effect, that means restraining effect here, automatically it may shows just like a cantilever is displacement. So all this will why it is happening means lack of connectivity one element or one wall to other wall. That's why technical they are saying the integrity. There are 4 walls are there. The walls, all the 4 walls not integrated one to one. That is the problem. If you provide one to one means you can have a scope. Of course, failure may be, damage may be different levels. But it's yeah, ultimate aim is the human loss you have to minimize or you have to make it 0. So before failure means a small time gap will available to evacuate the place. So that's why that's enough to evacuate the place of that inside the house. So property means we can get it back and later by helping of their own earning. Otherwise, the government may support. But once life is losses means that may be too bad for our country also. Next one. See here, pushing damage or separation of walls at intersection. See the real image is at the intersection it is totally damaged because of basically this is the brittle material. It may not permit the much displacement laterally. That too, if we are not providing the structural integrity, immediately lead to the collapse. With little time or no time, it may lead to the collapse. So small incident was you can see in the right side of the image. See, prior to that, sometimes the cracks may be propagated. The disturbing energy is very less means bearable stages means a crack may be propagated in this way. See here, this crack is propagated here. Still, it is the more frequency is more means automatically it leads to widened cracks. Up to certain stage, it may lead to the failure. So structural integrity, where you have to provide. The question again, that is the one doubt in our minds. We will see that one also. See here, one more thing. This is the stone masonry. This is a slab. Are you providing the structural integrity here? Simply resting on the walls. How we can provide the structural integrity? See the corners, lack of structural integrity. In plane or out plane movements. Anything, any one thing may be happened here. Out of the plane or within the plane. So within the plane means so you take the rotational effect. Out of the plane means only horizontal effect maybe comes here. Next comes by conducting the some experiment in the laboratory, we can sense the cracks here. See, closely observe this crack is the diagonal crack. So this also diagonal crack. Here also diagonal crack. Why it is not the vertical or horizontal? Why it becomes the diagonal crack? With the again analytical point of view, post analysis.
Professor,
Uh,
could you please try to wind up the session in 10 minutes? Last 10-15 minutes, we will try for a question and answer sessions and feedback session.
definitely.
Okay.
Within 10 minutes, I may close it.
Okay, thank you, sir.
Very little. So cracks is here. Whenever the things is there here, the shear force is acting means major consideration is shear force here. So whenever the force is creating here at bottom, let this is the building. So the oppositely it will go to the opposite reaction to give the building at a stationary point. So these two affect the shear effects. With this complementary shear stresses may act here. Probably all being in the strength of material, we might have known the complementary shear stresses. In order to close the moment effect to zero, so complementary shear stresses. When these two resolve this one means automatically it may be propagated in the cracks. That means if you resolve this one in the vertical direction, in this direction, in this direction, in this direction, diagonal, automatically weak in tension. So this may be crack, may be propagated. That is the one thing. See here. The opening is there, here opening is there, there is no lack of integrity and closing. Okay. See the connection. So here a separate band is provided here. That means in plane. If we take the in plane action, that means within the plane either movement or here within this plane only. That means that may be strengthened by using the some arrangements. That arrangements also we'll see. See, there is a lack of integrity with walls, entire roof has collapsed. Next is these are the examples. Alright, I said you shear, whenever the disturbance creates means a large gap will be created. So this may be try to push or move along this side. Then this type of cracks also you can see here. So this same thing, I'm going little fast here. So within this plane, not outside the plane, within this plane only. If you take this is the plane, within this plane. So here also out of the plane, this out of plane is coming. See here, out of the plane. This is the one plane means this material coming out of the plane. So few more examples here in plane and out plane. So here also same thing. One provision is see here, short duration I may complete. So here, sill masonry, wall and spiral here. So you have to make the integrity that I will show here. These are the examples for in plane and out plane. Moving to straight away resistance, how to improve the resistance. Check, I will check. So one more, generally in rural areas, you can provide the through stone. This is one of the, just like a recent one we are calling the shear walls. At one location through stone, that means this side to that side we are providing only one stone. At that part shear capacity is more by using the through stone. So one more prevention is you have to provide the mesh shear, especially corners. That's also possibilities there to reduce the effect. So here at corners you have to provide the bands, this connection. So here you are providing the one to one side to other side is the reinforcement with nut and bolt system. So here and here, see here, this is the rod here and here nut and bolt system. That means you are providing the resistance to bulge it. Next I'm showing few more images, very important images. See here through stone, already I said you some places here through stones. This may be in one view you can see 1, 2, 3, 4, 5, 6, 7, 8. These plates are act as a shear resistors. See the through stone in the cross section of the wall is acting. Whenever it cuts means cutting of this piece is highly difficult rather than the joint. So sometimes you can provide the mesh also. If mesh is there means confinement may comes to this masonry. So one more just like a layer of steel bars, you are providing steel having a tactile capacity. So that's why so increasing the capacity of the wall. So see here inside. These are the few images. I will show with one slide. I will complete all the things. So here all the corners is the plan. Corners you are providing the rod, you are running the rod here there. Is the diagonal cracks you can minimize. One more is very important one is staircase. Staircase joints you have to take care. With one slide I will show. See here, this is important. So here bands you have to provide. So this is the masonry wall, this is the tie beam, this is the plinth beam, foundation level, RC slab. Here you have to provide all round the one, just like a stirrup for the column. So here you have to provide lintel beams. So these maybe act as a confinement to the masonry. So that's why many times we'll prefer put a band all round. One is slab level or plinth level and roof, one is door level. So this you can see. One man sometimes this may be once you are putting the concrete means this adjacent side is the free space is there. This may act as a shear connector. See here, this gap is there. This gap. See this gap is there. This may act as the shear connectors. That means certain space is embedded into the masonry to the column. See the bands: plinth band, sill band, lintel band, and roof band. So these bands will act just like a stirrups for the column. Whenever the load comes disturbing an activity, it may buckle. So whenever the distance is little 1 to 1 means one step to other step means load taking capacity also more here. Otherwise, yielding capacity also more here. So the failure mechanism already I told you. Brick masonry. So this also same image, just like a keys masonry construction. So those are the precautions you have to take while constructing the masonry buildings. See, sometimes these rods also externally, the stirrups also we are providing lateral stirrups, confinement. Like this, bands you have to provide. Here band, here band, here band. Necessary means vertical rods also at regular interval you have to provide. Then you have to provide the mesh. Ultimately, what you have to learn is structural integrity is required. Get the intention. So unknownly see sometimes for the villages also we are providing the stiffeners in the form of stiffeners. So that's all about the masonry buildings.
Thank you, sir. Thank you very much for your insightful presentation. Your perspectives have significantly enriched our understandings on resilient earthwork structures. Yes, sir, if you allow, I welcome questions from the participants.
Yes.
Yeah, I'm requesting all the participants, if you have any queries, please, you can raise hand or unmute your mic and can ask.
Probably many participants are taking the food dinner. This is the hard time to listen also. One session is good, second session slowly the interest also may lose. Of course, some are maybe active also. That may be different case. Yeah.
I welcome the questions from the participants if you have. Otherwise, I'm placing the feedback
Mm.
feedback on session 2, session 3, and session 4 as well. Those who are failed to give feedback on session 2, you can avail this opportunity. Thank you very much, sir. Really, we appreciate your time. We deeply appreciate your efforts in sharing your knowledge with us. Thank you very much once again for accepting our invitation and giving time for us. Professor Shashidhar, sir, are you there?
So probably
Right.
is there?
Shashidhar, sir, are you there?
1 minute. 1 minute. He may join.
Yeah.
He may join. So strictly speaking, one more effect is there, wind effect. So far we have discussed about earthquake only. I kept wind effect also. So however, due to time constraints, I may close with the earthquake effect for masonry buildings. Coordinator, Raghubabu, I think Raghubabu, are you
Yes,
there?
sir. Sir, yes, sir. I'm here.
Yeah.
Yogi.
Yes. Just
1 minute.
Yeah. Meanwhile, I'm welcoming the participants again for the question and answer session. If you have any questions, you can, or else you can drop a text message in the chat box. And I request all the participants to give feedback on all the sessions if you failed to give in yesterday's session.
so nothing is there means can I leave the meeting? Let it be. We will wait for other coordinator, main coordinator.
Yes.
Ramana.
No, sir.
Sorry, there is some network connection with me. So I hope everything is fine, no?
Sir.
Hello?
Other coordinator has to tell.
Yes, sir. It's all fine, sir.
Yeah.
I
So
welcome. the participants for
So,
question and answer session.
yeah, on behalf of JNTU and Civil Department, I thank Dr. N.V. Ramana for giving an excellent presentation. Is a almost experienced faculty. Hope the participants enjoyed the session. Thank you very much. Take over, Raghu.
Uh, Thank you, sir. I again appreciate your time and expertise and perspective have significantly enriched our understanding on this topic.
Okay,
Thank you
right.
very much, sir. Thank you very much for
Right,
your
right. Thank you. Thank you for providing the opportunity and for all audience also. Okay.
yeah.
I'm leaving the session.
Yes, sir. Thank you, sir.
Any doubts is there from the participants? You provide in the chat box. Otherwise, you take the return way. Then I will answer to them. Okay.
Okay, sir. Okay, sir. Thank
Okay,
you.
right. Thank you. Thank you very much.
Dear participants, I'm reminding you again. Attendance will be tracked based on duration of your presence in the Google Meet. The Google form provided in this chat box is solely for confirming your attendance and collecting feedback on session. I'm requesting you all, please, you should ensure at least 80% of session and you need to provide feedback on each session. I have already provided feedback of 4 sessions here. Please give feedback on each session.
Sir,
Yogi, is there anything to say?
sir, I am
Nothing, sir.
Yoganathan.
Yeah, please, sir.
Sir, I am attend the mobile, sir. So I not the feedbacks not submitted, sir, today.
Now we provided in the chat box. You can.
Chat box maybe not providing the sir this content.
I'm not getting you, Yoganathan, sir.
Chat box I attempt the mobile sir section.
Okay.
Chat box is not given my mobile.
Then please text me personally, sir. I will provide you there. No issue, sir. We will help you.
Okay, sir. Okay, sir. Yesterday I will attend the classes. Today I will attend the classes, sir.
Yeah, sure. We will help you, sir. No issues.
I put it the not feedback attendance is issues, sir.
Yes, sir. We will provide you feedback, but attendance is not in our hand. It will be tracked by the Google Meet.
Okay, sir.
Yeah. Is there
Thank you,
any
sir.
question from the participants to take?
No, sir. Thank you.
Or else you can leave this meeting. Yogi,
Yes, sir.
is there any need to take?
No issues, sir. No issues. We'll collect the screenshot from the recording.
Okay. Thank you, everyone. Have a great night. Bye.
Yeah, we'll close the session, Yogi, Raghu.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah. So thank you, participants, once again. So hope we'll meet tomorrow sharp at 6 o'clock. Thank you very much.
Good night.
Thank you.
Thank you,
Thank you,
sir.
sir. Thank you, everyone.
Ah,
Uh, yeah, madam.
Thank you, sir. Sir, shall we leave, sir?
Yeah. If you have any questions, you can ask. Otherwise, you can leave.
Okay, thank you, sir.
Please don't forget to give feedback. We will close the responses after 15 to 20 minutes.
Hello. Sir, previously we submitted our feedbacks in yesterday only, sir. We can share our feedback now itself also, or previously it's considered, sir.
Please share the feedback for each and every session which is provided in the chat box.
Yeah, sir. Yesterday we are submitted for first session 1 and session 2, sir.
Okay.
Is it now it's possible to re-upload
No,
or else?
no. You have submitted it, right?
Yeah, sir. Yesterday we submitted, sir.
Then it is not an issue. Then it is not an issue.
Okay, thank you, sir.
Thank you.
Thank you.
హైదరాబాద్ ఆర్టీసీ క్రాస్ రోడ్స్ లోని సంధ్య ఆధారిత ప్రశ్నలు అడిగినట్లు తెలుస్తోంది.